Today we're going to be looking at the change of base property. So I'm going to take log base b of x and I'm going to rewrite it so it's the log of x divided by the log of my base b. And remember, it's the log of the argument divided by the log of my base. And remember that base is always the one that's tiny and small right after the word log. So we're just going to be rewriting our problems. It says rewrite the following using the change of base property. If I have the log base 2 of 25, I could rewrite this as the log of 25 divided by the log of 2. And here is my logarithm rewritten using the change of base property. I have log base 5 of 12. Using the change of base property, I could say this is the log of 12 divided by log of 5. On example 3, log base 0.5 of 5. So I could rewrite this as log of 5 divided by log of 0.5. Let's take a look at example 4. We have log base 2 of -4. Now, this isn't something that we've seen before because so far we have not worked with anything that had a negative number. Now, if we wanted to rewrite it using the change of base formula, we would say log of -4 divided by log of 2. But if they asked us to actually evaluate, this would be impossible. Because if we were to ask to evaluate it, we would get no solution. Now, the reason for this is because if I were to try to work it out, remember, we're trying to figure out, whenever we're looking at logarithms, what we're really asking ourselves is what exponent on our base of 2 would end up giving us an answer of a -4. I could rewrite this problem saying the log base 2 of -4 is equal to an unknown. And if I wanted to circle my base in my answer, I could say 2 to the x is equal to a -4. So we're looking for what exponent could I put on my 2 so that way I got a -4. Well, it's impossible. If I were to think about this, I could say, okay, 2 to the first gives me 2. 2 to the second gives me a 4. If I do 2 to the -1, I get a 1/2. Because remember, negative exponents move your numbers to the denominators. If I did 2 to the -2, I would get a 1/4 because anything with a negative exponent makes you do the reciprocal of it. So this is an impossible situation. That's why it is no solution. I just wanted to clarify that for you. Let's take a look at example 5. I have log base 3 of 8. We could rewrite this using our change of base property. I would have log of 8 divided by log of 3. If I had log base 2 of 13 is equal to y, I could rewrite this using my change of base property and say it's log of 13 divided by log of 2 is equal to y. On example 7, I have log base 2 of 512 is equal to x. I could rewrite this using my change of base property and get log of 512 divided by log of 2, and that's still going to be equivalent to x. For example 8, if I wanted to rewrite this using the change of base property, I would have to do a little bit of condensing before I could rewrite it using the change of base property. So I know that if there's an addition sign, I'm going to condense using multiplication. I write my log base 8 one time, and because it's addition, I'm going to multiply 9 times 11. Well, 9 times 11 gives me 99. So I have log base 8 of 99 is equal to x. If I wanted to rewrite it using my change of base property, I would have log of 99 divided by log of 8, and that's equal to x. Looking at example 9, I have 6 log base 4 of 2 is equal to x. So same thing, I'm going to have to condense the left side. My 6 is really an exponent, so I'm going to put it as an exponent on my 2. I would end up with log base 4 of 2 to the 6th is equal to x. Well, 2 to the 6th, I can actually work in my calculator. 2 to the 6th gives me 64, so I have log base 4 of 64 is equal to x. If I wanted to rewrite this using my change of base property, I would get log of 64 divided by log of 4, and that's equal to x. Thanks for watching as we rewrote our logarithms using the change of base property.